OMG, talk about a juicy headline. Common drug may extend women's fertility by years, early results show. So is this sensationalism and hype, or is there any truth to this? The truth is usually somewhere in between, so let's get into it. The drug in question is called Rapamycin, and this was originally FDA approved as a potent immunosuppressive agent used in transplant patients. However, you're seeing it in headlines and all over social media because it's creating quite a buzz when it comes to longevity medicine. Rapamycin is known to successfully inhibit or suppress the mTOR signaling pathway, and this is one of the pathways or signaling mechanisms behind cell death and aging. This figure is from one of the first studies ever published to show that rapamycin could in fact extend lifespan, looking at the rat model and showing that there was a 28% extension in lifespan in male rats fed rapamycin and a 38% extension in lifespan in female rats fed rapamycin compared to controls. Okay, here's where rapamycin becomes relevant to me, a fertility doctor. We know that the ovaries are subject to aging from the time that we're born. We're losing eggs all the time. And we start off with millions, and by the time we get into menopause, which is usually your early 50s, you have less than 1,000, and that's when you kind of run out of eggs and you stop being able to release them or to ovulate. Here's where anyone who has ever had an ultrasound and looked at their ovaries might be thinking, wait a minute, I've never seen 1 million eggs or even thousands of eggs at any given time. And that's because you have this concept of follicles being recruited or eggs being recruited from the resting pool buried deep inside the ovary that you never see. And every cycle, there's these waves of recruitment where a very small subset actually make it to the surface and become visible in these bubbles of fluid that we call follicles. So it is very normal to count 10, 15, 20, and some people have a lower number seen at any given time point on ultrasound, and some people have a higher number. And that is always a pretty accurate reflection of what the resting pool looks like, how many eggs you have left over for future cycles. But to be clear, we as fertility doctors, when we do IVF or egg freezing, we can only get to what your body serves up to us, and that is going to be a function of how many resting eggs are in that pool buried deep inside the ovary. So yes, as we get older and we have less eggs that are in that resting pool of follicles inside the ovary, you're going to have fewer that are visible at the surface on an ultrasound, and I'm going to have access to fewer should you need IVF or should you decide to go through the process of egg freezing. Now, if you're trying to get pregnant on your own and you're ovulating 1 egg every month, the number that are at the surface doesn't really matter. It's more about the quality or the ability to ovulate a healthy egg, which is also something that declines with age. Getting back to rapamycin, then in 2013, there was a study looking at the effect that this drug may have on the female reproductive system using the rat model. And this study showed that rapamycin did appear to successfully preserve a larger pool of eggs for a longer period of time. And the main mechanism of action, they thought, was that it prevented activation of the primordial resting follicles. And so it essentially led to less eggs being recruited and wasted each cycle. So yes, if it takes you longer to get below that critical threshold, then theoretically this drug could potentially help you to have enough eggs to ovulate longer and later in life. So the study in the headlines that everyone's sending me is a preliminary pilot study looking at only 50 women, and they randomized some of them to receive rapamycin 5 milligrams, which is a relatively low dose, per week for 12 weeks, so 3 months, and then the other group received a placebo. And they followed them for an additional 9 months, so for a full year, and they measured their ovarian reserve markers. Researchers are reporting that the initial results are encouraging in that there seemed to be around a 20% reduction in the drop in ovarian reserve markers over the course of the year in the women that received rapamycin. Taking rapamycin also did not appear to cause irregularity in the cycle or prevent them from ovulating. They are planning to do a follow-up trial that is going to be much larger, including at least 1,000 women, and I eagerly await the results of that trial because this is a very small preliminary study, and I do have some questions and concerns. I do find it very exciting that we are studying drugs like this that could change the game and maybe slow the rate at which ovarian aging, at least depletion of follicle count, occurs. But we need more data. We need to understand the mechanism by which there is a slowing in how many eggs are lost. The studies with the rat model suggest that the main way that we are able to preserve or slow the rate at which eggs are being lost from the resting pool is that there are fewer that are being recruited. And that to me is concerning as someone who focuses a lot on trying to maximize how many eggs we can get from an egg retrieval cycle. So it'll be interesting to see how the antral follicle count was affected in the women that were treated with rapamycin versus those that weren't. If it is in fact limiting how many are recruited or available, then that's not going to be that helpful for IVF because that's such a numbers game. Also, my biggest concern, and something that I think we really need to be looking at, is can these patients actually have an easier time getting pregnant? It's one thing if you're able to help people ovulate for longer and go into menopause later. That could obviously have certain beneficial impacts on general health and well-being and quality of life. But just because you ovulate in your 50s doesn't mean you're more fertile than the next 50-year-old, right? It's all about the quality of the eggs. So whether or not rapamycin can influence egg quality and the ability to make a genetically healthy embryo with high reproductive potential, that has yet to be studied in the rat model or in the human model. And so I think that this is way too early. This is very preliminary, and we need more data.